Yes. I know the title doesn't really give away what I'm going to talk about, so it's going to be about developers taking part of the on-call support. So if this is not for you, I won't feel upset if you decide you want to go to the other talk. There's also some smallish diagrams and stuff, so if you're over here, you may not see everything. So if you also want to move, that's fine. So you build it, you run it, why developers should also be on call. So, yeah, I'm Chris O'Dell. You can find me on Twitter, Chris Ann O'Dell. And I'm the lead for build engineering at Skelton Thatcher Consulting. We're a very, very tiny consulting company that focuses on, there are my books, excellent. Focuses on team-oriented mentoring to improve your release processes and delivery and that kind of thing. So yeah, I co-wrote this book with Matthew Skelton for continuous delivery with Windows and .NET as a kind of addendum to the continuous delivery book. It's free from O'Reilly, so you can download that and have a read. And I'm writing this one right now about build and release engineering as a team guide, so where we're going to expand on most of this stuff in a practical way. There we go, Skelton Thatcher, Team First Digital Transformation, 30+ organizations, UK, Europe, India, China. Come find us. So why developers should also be on call? Okay, I'm going to talk about some prerequisites, like the CD pipeline. We've had 2 talks about that today that I was in. One for CI in the other room, so you guys all should know all about this kind of stuff, CD pipelines. Telemetry, thanks to Pierre, you should also be an expert in that too. Metrics-driven development, product ownership. These are prerequisites, I say, for developers on call. And then some techniques. So on-call is a first aid situation, effective incident follow-up, running an on-call rota and preventing some burnout. It's icebergs, okay? It's literally just the tip of an iceberg, this talk, because the subject matter is massive. The subject matter is huge. There are whole conferences, books, movements around this whole subject. Velocity conference, go to that one. And yeah, it's just huge. DevOps Handbook has just come out. I am not going to cover everything. There's no chance. So the continuous delivery pipeline. Now you're going to have trouble seeing this because this is not as big a screen as I thought it would be. So most CD pipelines will look very similar to this one. You'll start with some kind of analysis on the piece of work, where you're pairing with maybe a BA, PM, whatever, and you're figuring out what that piece of work is, or breaking it down into story points or something similar. Before you get onto the development TDD cycle, the feedback loop there between the pair review, back and forth with the red-green cycle of development. And then you'll commit it into source control, which will automate some builds which will either pass or fail, and you take that feedback into your development process. Again, if those pass and fail, you'll do some acceptance tests, possibly after deployment or something in a QA environment, and that feeds back into your development too. You may do a final review before you release it. Again, this may be with the same people for the analysis. You go back to the PM and go, this is what I delivered. Is this what you wanted? And then you'll deploy it. Pretty standard, right? You've probably all worked in a pipeline very similar to this. Do you see any bits missing in this pipeline? Anything after this, exactly. There's a feedback loop missing here. I see that this is a massive feedback loop. You stop here and then there's nothing else, okay? And then after deploy, right? Feedback loop right there. So as you just said, Pierre, most people talk about CD up until deployment and then nothing after. Like there's a whole bunch of information coming back that you just ignore, pretend it doesn't exist. So, in most traditional companies, you'll find that the reason for this is there's a wall between dev and ops, okay? That wall has happened over time via culture and the companies, so based on incentives. Development are incentivized to release, make changes, get out new features. Ops are incentivized to push the other way for stability. No risk, no changes. They want it just running and working. And that's where the wall just gets bigger and bigger. And you lose those 2 feedback loops. They're just gone. Having a separate operations team creates a divide and simply doesn't scale. It puts the onus of responsibility for fixing an issue on the wrong team. So that's Jerry Parsons, Airbnb software reliability engineer. We talked about site reliability engineering earlier, so they're kind of a specialized team for ensuring reliability for your applications. And you can use metrics, telemetry, to kind of bridge that wall, to kind of make a hole in it. So I'm going to talk a bit about that. So telemetry is sending operational and business data from your applications to gather it all together. It's almost the stuff that Pierre talked about earlier. It's gathering logging, gathering aggregated. Give me one moment here, I'm a little bit flustered. Okay. Cool, so what's aggregated logging? Does anyone know Sam Newman? He's written the microservices book. If you haven't read it, do have a look. So aggregated logging is when you get all your logs off the machines where they're generated and forward them to a central location with querying. Okay. Because if you're in a distributed system, you can't SSH onto every single box to get information. So something like the Elk stack, which is Elasticsearch, Logstash, and Grafana, is extremely popular for this information. So have a look at that one. Alternatives, if on SaaS, are log entries, Papertrail, and Logly. So if you don't want to install your own stack, there are actually hosted alternatives out there if you need something in the short term. Metrics themselves. So this is a Grafana dashboard. So this is collecting things like memory, CPU, how many people are logging in, server requests. It's just a demo one. But for yourself, you'd probably store whatever's relevant to your company. SaaS options there are Geckoboard, Clipfolio. And metrics-driven development is the use of real-time metrics to drive rapid, precise, and granular software iterations. So that's taking those metrics that we've gathered, all that logging information and everything, and kind of flipping the development process on its head and using that data to guide what you do next. Okay? So if you are, for instance, you need to focus on conversion rate or something, say particularly a particular conversion of a particular type of customer. So you'll get that, you'll be able to start gathering that particular one metric, and then you'll make a change in the system to try and drive that metric up. So where you've broken that wall down by collecting all this information, you're now using it to drive change. But there is a gap, a mental gap, between what you think your system is doing and what your system really does. And the metrics can help with shrinking that gap quite a bit, but you're still far removed from the system. You're not the person or the team or the people responding to the actual system working right now. There's a talk here by Coda Hale about metrics and metrics-driven development, which I recommend. So I see developers on call as an evolution of metrics-driven development. So CD, to begin with, which then you use that metrics and information to create metrics-driven development, and evolve it even further to put the people who created the features on call, on support, to receive that information real time and real live. So steps on steps on steps. Shrinking that gap, making that wall as small as possible so that final two feedback loops feed straight into the original source information, the developers. Bottlenecks. I want to talk about organizational scaling bottlenecks. So after a point in pretty much every company, when they get to a certain size, it's these software and performance bugs that occur more often than infrastructure bugs. This is even more true if you're in the cloud, because a lot of that infrastructure information is now offloaded somewhere else. And the business I've seen find it harder to hire people with operational skills at the same rate as they hire developers. So you end up with about a bottleneck, again, into the shape of that wall that we talked about earlier. When things are broken, we want people with the best context trying to fix things. So this is Blake Scrivener from Netflix's RSE team. So what I'm pulling this quote out for is that, as we spoke a moment ago, about how it's more software and performance bugs that occur, the people who develop the application are more likely to know how to fix it than the operations team. Okay. Oh, I've got here in my notes, developers sleep soundly whilst ops struggle to handle problems they're unlikely to fix. That's pretty true. So, big part of this process, moving over to it, is actually needing to collaborate with the ops people. You need to understand and improve how your application, and applications in general, operate in production. It's very unlikely that it works exactly as you imagine it does. And if you don't have a huge amount of experience being on the front lines, say you've always had a really big wall, there's a lot to learn there about logging and metrics and just keeping things running. There are whole books on this, actually. I'd like to recommend the Web Operations book by John Allspaw. So yeah, improve your knowledge of highly available systems and use that to feed back into the development of the product. So your experience and your operational team's experience can shape what you work on next to improve your application. I think this is only easily done if you have ownership, if you own your product for its entire lifetime. And you go in with this mindset from the start that when you're going to create this new thing or take on something that exists, that it is now yours, you own it, you ensure that it grows very happily, and that whilst it's running and it's doing everything it needs to do, and that you're going to look after it until it's finally decommissioned for some reason. I see this as a prerequisite of the autonomy, mastery, and purpose kind of triad. Are you guys aware of that? So the idea is that for people to be really, really good at a creative knowledge-based job, you have to have some level of autonomy that you decide what you work on. You have mastery, as in you know your tools, you know the area, so you feel confident in it. And you have purpose, so you know what you're striving towards. So I think ownership is where you can work towards getting those three things. So ownership means that you now, because you own it and you're on call for it and you're supporting it, you have a greater freedom of choice with this application. You can change it and rewrite it, or do you want to really? I know you saw this joke earlier. But make sure that now that you have great control and ownership of your feature, you are also responsible for it. So you're going to be careful if you make any big changes. So first, before you start rewriting this application that you now own into, say, Node.js backed by MongoDB, that's not current, is it? That's just backed by whatever's cool right now on Hacker News. Learn by fire, if need be, how to become experts in supporting your application as it currently looks before you go ahead and decide to rewrite or change or decide that it needs a kick up the butt. So learn about how and what metrics and monitoring information made tracking down issues easier or harder, so that when you look at a new system or a new tool or whatever, you expect those things to be included. Like how easy it is for this new thing that you're going to do to reboot it, to debug issues, to get a stack trace out. If what you're looking at doesn't provide a similar level of monitoring and resistance, come back to the tool in about a year where the rest of the open source community is caught up. And I think that operating in production is an oft neglected use case of a product. So when we're designing a product, we think about how it looks, the experience of the user, the experience of possibly deploying it, but we don't always think about the experience of running it. So I think it gets left behind and neglected until possibly too late. So if you're owning it, if you have the autonomy, the mastery, and the purpose to look after your thing, and you are on the hook for it, maybe you'll be more inclined, hopefully, to consider how it runs in production. So I say that being on call for your own product is more about risk management than control. All that cool stuff was before about how if suddenly that you're now in charge of the invoicing system that's written in something really horrific like Java 6 or whatever, and now you're thinking to yourself, I'm going to rewrite it in React and it's going to be amazing. Yes, maybe it will, but think about how risky such a change is. I mean, you can make it small incremental changes instead. You're the one doing it. You decide. If you decide that that you'd rather take it into little chunks and rewrite little pieces at a time. Or if you decide that releasing on a Friday afternoon is fine, it's fine. You're the one on call. You take that decision. Okay, little subject change. On-call engineers are the first aiders of software engineering. Okay, so I've done a first aid training, the one the company sends you on for a day, and you spend a day doing this, and you learn the rhythm, and you learn how hard it is and exhausting, and when you get to an incident or an accident or something, the first things you should do: check the airways, check if they're breathing, check for circulation. And I see being on call a bit like a similar reaction. You have a set of tasks, a set of things that you are pre-subscribed that take your mind into a structured way of handling a situation. So just for fun, I thought I'd see what would happen if I tried to invent my own equivalent to this, right, for being on call. A for assess. Triage the incoming alerts. So if you're getting so many alerts coming at you, or a alert at all, decide by the importance of this alert. B, blast radius. So what applications are failing? What's the impact to the system? Who is being affected by this alert, this incident? I mean, if it's a small group, then maybe, or if it's only affecting Australia and they're asleep right now, different response maybe. Compensate. Apply mitigating actions. Okay. So for this kind of thing, it'll be whatever you need to do to stop the bleeding. So like with first aid, just get the person breathing again, get the system running again. It probably needs more work. Okay. So what compensating actions are there? You may have the ability to turn off a feature flag. So you've got a new system, a new thing you're trying out, and you developed a feature flag to turn it on to, say, 10% of the users. And it's got a problem, you turn it off. System's breathing again. Apply some kind of graceful degradation, where, say, you were using a brand new fancy-dancy search system, but it's not performing very well, so you put it back to the old one. Redeploy a known good version. So if you knew that version 2 was fine, just roll it back, redeploy version 2. Turn on load shedding. That is a concept where you say that we're getting too many requests at this point in time. We're just going to reject 50% of them at the load balancer because you just can't handle it. Now, all of these things you've probably noticed, and there's so many more, it's why there's like books and conferences and stuff, need to be coded in. Other than the rollback, which still needs a consideration about data migrations and all this kind of stuff, you need to code them in. You need to have developed your application to allow these as possibilities of compensating actions. So again, much like with the metrics-driven development, if you're going this route where you are on call for your application and you are supporting it and you want the ability to compensate quickly, you need to flip the development on its head and think about these issues so that you've got these tools at hand. One thing you don't do, though, is investigate the root cause during an incident. It's not the right time, once you've got it breathing again, to try and perform the surgery. It's probably late at night, you're probably under stress. It's that separation between paramedic and hospital, right? You've got it breathing again, but you don't deal with that root cause resolution during an incident, during outage, or once you've got it running again. You are probably under stress, you're on your own. Leave it till the next day. So we'll do some follow-up now. The first thing to do the next day is to hold a blameless post-mortem as soon as possible after the event. So a post-mortem is very, very similar to a retrospective, but with a particular focus of the incident. There are two reasons to doing a post-mortem I can see straight after an event. There's two things you're trying to do. The first one is that root cause investigation to find out where it came from, and then and the second one is to go over the actual steps that were taken during an outage. So as in, the alert came into, say, my phone at 10:59 at 11:05, I was logged onto the box. At 11:10, I was struggling to find out what was going on. I had to call in my manager. You know, this kind of thing. So there's 2 steps. What went wrong and how we handled it. Reasons being is so that you can try and improve that process at the same time as trying to improve what happened. And any kind of mitigating fixes that you come up with during this meeting go to the top of your backlog. Now, this is in that prerequisite world where you have the autonomy, the ownership, so you can decide that these things go to the top of your backlog. You get them fixed. And then I think it's really important to run some kind of presentation where you do a show and tell of what happened after this incident to your colleagues, to the rest of the wider engineering team, to share the knowledge around so that your organization as a whole learns from it. There may be some kind of async or caching issue that you discovered, and you hope no other team has to come across it. Now, the reason these mitigating fixes and stuff go to the top is because, as a quote here from John Allspaw, is mean time to recovery is more important than the mean time between failures for most type of failures. So mean time recovery is how long it takes you to get it breathing again. So that's why in part of your post-mortem, you should be focusing on not just what went wrong, the server fell down, but how long it took you to get it running again. And yes, the web operations book, very true. Okay, so the ownership of runtime success belongs to you guys now. So it's very important that it succeeds. If your application does not succeed in production, why does it exist? It's now part of the things you need to look after. I want to mention a couple of post-mortems to go and read that have been really, really big recently. If you haven't read them, do look them up. There's the GitLab database deletion. I'm seeing a few nods, so some people have read this, right? Yeah, I like it, it's fantastic. If you haven't read it, please do. They managed to delete their database in production, and the backups didn't work. Fantastic. And they've gotten the whole chat logs and everything, so they've been very, very open about it, and I don't think they'll ever do that again, and they've learned a lot about like what to change in their system, what kind of things to avoid so it doesn't happen. The other one is obviously the S3 downtime. S3 doesn't go down, right? Well, it did this once. And they've written a whole post-mortem about it. Not quite as good as the GitLab one, because they had their chat logs on there. But the S3 one's pretty good too, because they described the fact that a server was taken down, but it was the wrong server, which was the controller for all the S3 servers in there. And they didn't know, and it was just a mistake, and it's fantastic. Like, find more post-mortems so you can learn from them. They're just brilliant. And the whole point, as well as the mean time to recovery, is to never fail the same way twice, okay? Those 2 companies are going to be checking their backlogs, backups are working, they're going to be checking that it's not possible to delete the S3 controller unless, 3 people turn keys at the same time or something. You just want to make sure that you do it once, fine, it's a mistake. You do it twice, okay. I want to talk about promoting a sense of safety now. So these are the tires around a racing track. So if you're going really, really fast, you need to have safety provisions created as part of the process. Cars come off the truck all the time. Accidents happen. They just try and make sure that they happen in a way that people still survive. So, I've gone too far. Okay, so allow for failure and provide support for improvement, and create a culture where on-call is normal and respected. And by that, I mean maybe consider placing some C-level people on call, maybe as execution only, as escalation only. So if your team lead or head of department is also on there, so they only get it if some issue doesn't get answered enough. It shows that your company as a whole is taking seriously. So if your culture does believe in this, everyone is part of it. Okay. So alerts and issues need to be pushed out to the engineers. Do not expect any engineers to sit and watch logs. You've got your pretty graphs, you've got your pretty logs, but on-call and on-call support is not sitting and watching as bad things happen. If that's what you need, if you need like that much response and someone watching the logs, that's shift work. You need to employ someone for those hours, except that they are now something you need to just have as part of someone's job. Use an alerting tool with built-in rotations and escalations, such as PagerDuty and OpsGenie. I've seen companies use spreadsheets with a bunch of telephone numbers in it, and they just say call Fred first, followed by, that doesn't work in a fast-moving system. And you're not gonna. So these tools, these ones are fantastic. They send the alerts to you, and you can create schedules and shadowing and overriding escalations. Sorry. So if the first person doesn't answer their phone in enough time, it'll get picked up by someone else, say 5 minutes later, and it'll go through a whole cycle of people before someone picks it up. And so that gives you that safety I was talking about earlier. That if you don't pick it up in time, someone else will be there. Say if you're in a tunnel or whatever. So rely on these kind of things. I think they're fantastic. Oh, and supply any kind of hardware that may be needed if necessary. So people will need to be having laptops if you expect them to be out and about, that kind of thing. This is homework. It's a stereogram. I didn't even know they existed with text until about 2 weeks ago. You know, the 3D things? Yeah, I'll put the slides online next, and you can try and figure out what that is. It's just homework. But the context of that one is signal to noise. Okay? There is a signal in all that noise. Alerts should only be used when we'd be happy waking someone up. There's a lot going on in your system. Once you've started tracking it, once you've started getting that telemetry, you're going to need to know what floats to the top and needs attention. And that is something that you're going to have to get to over time. You need to have, your alerts need to be informative and actionable. What I've got written here in my notes is the fire brigade respond to all call-outs, so should we, which means we need to reduce call-outs unless they're really, really important. So initially, if you put an alert system into whatever application you've got right now, it may be quite noisy, and it may be hard to tell with what you need to look at and what you can probably ignore. So you'll refine it over time, possibly as part of that post-mortem process. Like you could say you got loads and loads of alerts that were telling you something that was just not helpful. Just get rid of them. And it's to actively avoid alert fatigue. So I've been in places where it's considered not good practice to turn off a flaky alert or turn off the equivalent with testing. When people say this test isn't providing any kind of information, it's just noise, it's just going red and green depending. You need to you don't want people to be too tired of alerts that they stop listening to them. They need to mean something to everyone. So it's an ongoing process to fix that one up. So some tips, some actual tips of running an on-call rota. There are so many. I've got this link here which has loads and loads and loads of tips. These are from the ops people. So from the ops world, they've been doing this for so long, they know exactly what kind of things make a good on-call rota. But I've stolen my favorite ones out of this particular blog post. If you're going to be on-call on an on-call rota, no more than 1 week at a time, because people need their rest, and it's a week is quite a long period actually. It includes a whole weekend and a whole midweek stuff. So I think you should change over on a Tuesdays so as to avoid bank holidays. Most people when they first start setting up an on-call rota think Mondays are a great day, right? You just had your weekend, you switch your on-call on a Monday. But the problem is in the UK, I don't know about Ireland, most of your bank holidays are on a Monday. If they move around Ireland, so be it. Pick a day when most of your team are around. Pick a day when you know that you can probably have an on-call where you can switch over in person or at least by voice or whatever, so you can hand over any notes. Have an onboarding process for new engineers. Now, I've been in a company I went to recently. They said that the great way to get a new engineer up to speed was to put them on support. Woo! Okay. I think that's not particularly fair on anybody, that one. So I suggest developing a process that helps them get up to speed. So shadowing on call. So you have one person who's the lead on call responsible and someone else who's the shadows. So alerts go to 2 people and you'll work and pair on any kind of issues. And then swap over so the new person becomes the lead and the other one is a shadow. Whatever your process is, that's my suggestion. agree a reasonable SLA for alert acknowledgement. So what I mean by that is say to people or figure out between yourselves that you want an alert acknowledged within 5 minutes, for example, and that you need someone with a laptop open within 10 and looking at it. Whatever your times are, you decide. But if it's any shorter than that, and you need within 1 minute or 2 minutes, you're back to that problem of it not actually being on call, but actually being shift work, and you need people on site. The reason for this is that everybody knows what to expect. So it means the person that's on call knows that they need to no longer be more than 10 minutes away from a laptop and an internet connection, that kind of thing. And that the people who are possibly in a call center or whatever that working for you know that they've got at least a 10-minute wait before they're going to get actual support. And have the escalation policies around which ensure that more people get brought in if need be. And that those people are aware they're going to get brought in if there's a major problem. I think another part of clarity is agreeing areas of responsibility between developers and operations. Now, I, at some point during this presentation, started calling everyone engineers instead of ops people and devs. You may not have noticed, but I did. And I've gone back to just right now saying dev and ops. Reason being is that there are the reason for all of this is about knowledge and experience and specialisms. And the reason we're putting developers on call and you want to be on call is because you have the experience and specialism of the application. But the operations people still have this specialism in the infrastructure stuff. So if you agree between yourselves that developers from anything application upwards and ops and infra from anything down, and possibly the monitoring stack and whatever, there's clarity about who handles what and less kind of confusion if an issue occurs across in one area over another. So I just think that's a clarity exercise more than anything else. App health and performance and excellent. Ops responsible for underlying infra and monitoring stack. Cool. As you can probably gather, it can get really exhausting and really, really tiring to be on call all the time. Thank you. So, burnout. Again, this is a big thing in the ops world. Burnout is killing us. John Willis, co-author of the DevOps Handbook. There's a whole post here he's written, if you haven't written, where he talks about how this lack of rest and relaxation in the ops world, which we will be part of if we're also on call, causes people to eventually not just burn out to such a point that it is actually causing people to kill themselves. So be mindful of the cognitive weight of on-call. Okay? Even if you have the most stable system in the world and it never alerts, you are never going to be able to sleep without knowing that your phone is going to go off. So it's always there. So no heroes. No person who always goes on calls thinking, yeah, it's fine, I can do it, don't worry. Look after each other. You try and take that responsibility, share it around. So ensure that the team that you have is large enough to allow for rest, sickness, and holidays. So personally, I think a team needs to be between 4 and 6 people, maybe actually no, 6 to 8 people. So that means you're on call every 6 weeks, okay? If you do 6 people. Any shorter than that, say if you're on call once a month, if someone goes on holiday and gets sick, you're then possibly to cover for them on call like every other week. And that's just gonna eat away at your home life. You're gonna end up in a real bad place. So I reckon 6 to 8 people will handle that. And allow for engineers to swap and move their cover around. Now, I've come across a place where they have gripped it really tightly, like this is your schedule, you've got this week, and blah. That's gonna add to that stress. So allow people to switch weeks or swap and say on Tuesday I've got a parent-teacher meeting I need to go to, can you swap with me or whatever. So don't try and control it, trust your team. And part of the autonomy and ownership is to ensure that your engineers have the authority and space to improve the applications and therefore improve their life of being on call. Again, put the part of the fixes to the top of the list and make sure that the company, if you can, as a whole supports that. Compensation over reward. Now, on-call does need to be compensated for, and I like to use the word compensation because there is a tendency, it's something you're going to have to figure out yourselves, but in some places, it's treated almost like, because they pay quite a bit of money for on-call, some people will take a lot of on-call so as to get the extra pay packet. And they end up in a cycle where they're relying on that money, and they take more and more on-call effectively to maintain it. So there's a balancing act, and I don't have a very simple answer. You have to feel it out between yourselves, where it's just enough to be compensated, but you're not also feeding into that cycle of where people are spending too much time on call and ending up unwell. So I like this picture because the carrot looks pretty sad. It's like, yeah, it's somewhere in the middle. So there's compensation over reward, I think, is what's important there. Money only goes so far. You're always trading on goodwill. People will go somewhere else for work if they end up tired of it. Maybe time in lieu, that kind of thing. Someone I was with in the past suggested that we look to other industries for this kind of thing, maybe medical or whatever, however they compensate it. But it's something you need to figure out yourselves and figure out what works best for you guys. Here are some companies where developers are on call. Amazon, Just Eat, Netflix, PagerDuty, Airbnb, Datadog, DigitalOcean, Skyscanner, Google, Spotify, Dropbox. I believe, at least in the internet industry, anything that's web-based, anyone's company that's web-based, developers being on call is fast becoming an industry standard. So we'll get really, really good at this stuff. I think it's going to be coming to pretty much any internet-based job within the next few years. So to sum up, take pride in your services, take pride in your applications, make them battle-hardened, make them like something you're so happy is out there, and like, yeah, but without destroying your team, without taking the on-call so far that you'll fall to bits. So I think if you build it, you should be running it. Book. Me. Thank you. Yeah, I'm okay for questions. Yeah.
Cool, so if there's any questions,
Too many boxes.
Yeah.
Cool.
Mm-hmm.
Hi, good talk. Seeing you makes us realize that we are not that bad in support there. Like we have engineers on call.
Excellent.
We've been there for a long time. We had a
Excellent.
phase of only 3 people. Now we have 6. It's good. It's healthy. But one thing that you talk about ownership, and that's something that is always coming back and forth there. Like if we have a problem in production, have kind of a team that has our own plans and everything, but we are allowed to be disrupted to deal with whatever problems comes in. But and the other teams are pushing features. But if something happens, they push their feature. Not necessarily they are the ones on call. Actually, most of the times they will not be the ones on call, and then comes back to me or other guys that are on call. And we care about this ownership, but at the same time, how you balance, because some of these things needs to be investigated the day after.
Okay.
And
so you're saying that in where you are, you have developers, engineers on call, but there's a disconnect between the ownership and the responsibility.
Sometimes, yeah, you can't always guarantee that the guy that will be pushing the code will be the one on call. And you said about
why is that?
Yes,
I think that needs investigating.
You said about the life cycle of something. I pushed the future, and it was good for 6 months. Then something changed, break, and it's hard to detect.
So in that instance, like you say, it's more organizational, the problem there is. I would say there's not much you personally can probably affect unless you can get a conversation between people who help organize your actual company, so that they can try and rearrange the teams and ownership to make a more clearer distinction between the ownership from one end of the system to another. They need to understand that themselves, the people that make the teams, the people that make what's the authority and responsibility, they need to understand that this needs to be restructured. Maybe get them some books or something. I'm not quite sure.
Oh, no, it's not an easy to answer.
It's not easy.
I just wanted to see if you had something that I can think about on this.
There is a website called devopstopologies.com, and that talks about team structures that can promote better DevOps operations. So you can have a look through that and see the whole ideas of different structures. And maybe if you pass that one up, you can show that, if you're structured this particular way, the responsibilities are clearer. or this particular way is like an anti-pattern, which it sounds like you're dealing with an anti-pattern there, where it's not clear who gets to deal with the responsibility of that incident. So yeah, try that website. Thank you.
Thanks.
Anything else? Go at the back.
Yeah, it's nice to hear like our stories that we can all relate to as well, like our kind of. But like, I got a tricky question. Like, I was seeing this video from Strong Loop, I think, where the head of engineering was saying that like they cannot rely, for example, on Amazon as a cloud provider for their databases, web apps, so on. So they are prepared to deploy their apps into DigitalOcean or some other provider, just because their business is like they earn money from their business, so they cannot rely on the cloud service like that. Can I get your opinion on preparing for such an event? It's like
why people pick different cloud services over another?
Like if you should be prepared for an outage.
Of course, yes. Even DigitalOcean will have an outage.
Oh yeah, sure. But
exactly.
To deploy the app to another provider.
Oh, right. Like a DR, effectively, the multi-provider kind of thing. I think that's a fallacy. That's almost like, I think that most of these clouds are big enough that you can probably say, at least in Amazon's case, I don't know too much about DigitalOcean, you can go across different regions and you get the same effect, but without the level of pain of dealing with two providers. So it's very, so unlikely that Amazon will lose more than one region. So if you spread out that, I think you get the same effect. The pain of supporting two clouds would just be...
Oh yeah.
You'd lose so much time and money trying to get parity. I don't think it's worth it. Use the advantages of the clouds that you're in, whichever one it is, to spread out your risk. That would be my answer.
Cool.